Hey guys, this is a video about friction. It goes along with that friction review questions problem sheet that you have. Couple definitions I just want to revisit. One is net force. So you notice it says that net force is the vector sum of all the forces acting on an object. That means that it's the force that is left over when all the forces are added together and they sometimes cancel out. So it's not the total force, it's different from that. So let's say we have this object right here. We've gone through this before. What kinds of forces could be acting on this object? So we're going to draw forces going from the center of the mass of the object. It's a free body diagram. Our weight force is going to be acting down. That's equal to negative mass times the acceleration of gravity. And we are going to have the normal force, which is equal and opposite in direction going upwards. I'm going to draw that here. Fn normal is going to be equal to mass times the acceleration of gravity again. So if you know the weight, you know the normal force. Okay, so now let's say we have some other forces acting on this system. What might they be? You could have a push or a pull force. We'll show that like this. I'll call this F push in this case, and that is going to be going in the direction of motion. And then we're going to have friction. That's our force that opposes motion. So here we've got friction right here, force that opposes motion. So we can just show this always acting in the opposite direction of the push or the pull force. And that's going to be going back like this. And how big that force is going to be determined by something called the coefficient of friction. So let me just write this in here. F friction, that's with a little f there. And so let's take a look at some of the different equations that you're going to need to know for this section. So how do we find the force of friction? Force of friction, capital F with a little f, is going to be equal to, I'll draw this also in red, mu, that's the coefficient of friction. It's be a constant for any two surfaces. And that's going to be times the normal force because it's related to the mass of the object. So mu times Fn, the normal force, that those are going to be in newtons, right? Because force is in newtons. So that's probably our most important equation that we need to know for this section. And you'll notice that you can rearrange that, right? Like any of these equations. So you could say that mu is equal to the force of friction divided by the normal force right here. Okay? Now we're going to look at net force and what that has to do with friction. So since net force is a vector sum of forces acting on an object, we're going to look at both the direction and magnitude of force. So with the y forces, we have the normal force and weight. They are going to cancel out. So our net force in the y direction is always going to be 0 for the problems we're looking at. And so we're going to be concerned with forces acting horizontally or on the x-axis, and that's going to be our push force and our force of friction. So it's a relationship between those two forces that is going to determine our net force horizontally or on the x-axis, and that's going to determine whether or not an object moves. So we're going to look at two different situations then. Let's just move our screen up here a little bit. And so our two different situations are going to be if we have a stationary object or object moving at constant velocity. Those two situations are the same. That'll be 0 net force, or an object that is accelerating. Okay, so we're going to be looking at the net force. So I'm going to say F net. And what would I set that equal to when we're talking about the x-axis? That's going to be equal to our, whoops, that should have been in green, right? I'm going to say it's equal to force, our push force, and that's going to be minus the force of friction, okay? So only if we have more push force than we do friction, would we get motion? And so in a case where that is equal to zero, where there's forces exactly balanced, that is when you're going to have a stationary object or an object that is moving with constant velocity. We'll say constant v, like that. Okay. And most of the problems that we deal with on the assignment that we had on friction have constant velocity. So we can set this equal to zero. And so our other situation, we have an object that is accelerating, then our F net is going to be equal to that push again. Same thing, push and minus force of friction. And I've made myself run out of space here, but basically I'm just going to write that down here. That's going to be when it's not equal to zero, and that's when you have acceleration. Okay, so you're going to have a little excess force. Now, you might be wondering if force of friction could ever be greater than our push force, and it actually can't be. Force of friction is going to increase until it reaches its maximum, and at that point is when the object is going to start moving, and that would be acceleration. So if the object is already moving, is moving at a constant velocity, that is also a case when your force of friction could be exactly equal to your push force. Okay, so some other things that we want to think about with the version of the equation that we have here is that when F net is equal to zero, what we can say then is we can take this F push, force that's being exerted on the object, and we're basically getting rid of net force, right? So then we just set this whole equation equal to zero. And in that situation, right, we can add force of friction to both sides. And when we do that, we end up with our push force being exactly equal to our force of friction. And that's really handy because sometimes they give us this push force, and that means that we already know our force of friction if they tell us that this object is stationary or moving at constant velocity. Okay, and that is going to be the case many times. It's going to be an object moving at constant velocity. So therefore, if you know the push force, you also know the force of friction. And so one more thing just to say about that then, if you know the force of friction, that means we went over that equation up above, and that means that you can also set that equal to mu times the normal force, Fn, right here. So that lets you do yet another variation on that equation. So those are some pretty handy things to know about friction. I think that should set you up well for solving the problems, and I go through those individually in my next video.